In this video, we're going to walk through a calculation using the equation that we just introduced for Gibbs free energy. So in this problem, we've been given information about enthalpy and entropy and temperature, which we'll need to plug into our equation that we've developed for entropy as it relates to enthalpy and entropy, or sorry, free energy as it relates to enthalpy and entropy. So the one problem I see initially is that my units don't match. And so I need to do a few conversions before I directly plug into the equation to make sure that all of my units for energy are either kilojoules or joules, and all of my temperature units are in Kelvin. So that 25 degrees Celsius, I need to add 273 to it to get 298 Kelvin. And then I can convert either my entropy into kilojoules per Kelvin or my enthalpy into joules. I'm going to choose to go with my entropy. So that is plus 142 joules per Kelvin. I'm going to multiply that by 1 kilojoule per every 1,000 joules for a value of plus 0.142 kilojoules per Kelvin. Now I'm ready to actually plug in these values rather than that 25 and 142 into my equation. So I'm going to set this up, and it's just kind of like plug and chug at this point. That free energy value is going to be equal to my enthalpy of 95.7 kilojoules, positive. I'm going to then subtract the temperature of 298 Kelvin times that entropy of 0.142 kilojoules per Kelvin. Plugging this all into my calculator, I am going to get a value that's equal to 5.33. Actually, let's do it like this. Sorry, that is equal to 53.3 kilojoules. So is this spontaneous or is this not? I'm looking at a Gibbs free energy value that is positive. So if that free energy is greater than 0, I do not have a spontaneous reaction. So not spontaneous.